Welcome. So today we're going to talk about what's possible with cloud functions for Firebase.
I'm Michael Bly, the engineering lead of Firebase hosting and the Firebase command line interface.
And I'm Thomas Bolden. I'm the engineering lead for cloud functions for Firebase. So, Michael and I come from a background in startups. And we noticed that we had the same rules for how to build a product. And it's carried us through both startups and corporate life. So we thought we'd share them with you. The first part is the most fun. You come up with an idea that's going to make you rich and famous. This is when you get to daydream about how you're going to change the world. And the second part is coming back down to reality. Because it's going to take a lot of time and work. And you have two choices for how you want to proceed. The first option is to focus on engineering. And this can be a lot of fun to build something rock solid. You get to implement all those cool algorithms you read about in school. And if you're doing this project as a learning experience, that's a fine idea. If you're doing this project for impact, it doesn't tend to end so well. So alternatively, you can focus on the user and your market fit. Who are your users? What do they want? How can you quickly and efficiently build something that they're willing to pay for? If you can answer these questions, you're on your way to a successful business and a top post in Hacker News. So you should focus on your market fit instead of engineering. But at the same time, you can't actually screw up that engineering. You don't want your product to collapse as soon as it starts becoming popular. Otherwise, your best outlook may be forever fighting this mountain of technical debt. And this is why we love Firebase. We took a break from startup life to work with Firebase because we think that developers should be able to enjoy their work, build a scalable product, and do it quickly enough that they can focus on what's really important.
So before we dive in, I want to talk a little bit about the history of app development. For a really long time, the dominant way to build software was based on request and response. I had a client that could be a desktop app, a mobile app, a web browser, and that made requests to a server, and then the server sent some kind of response back, and that was how I built a connected application. Now, of course, it wasn't actually quite that simple, because in reality, the server needed to get its data from somewhere else. So in reality, I had a client that sent a request to the server that sent a request to the database responded to the server responded to the client, and that's how I built my application. And of course, if I have many clients, I'm making many, many requests. And every time I want to see, has something changed? Is there new data that I need to be aware of? That's a new request. So this model worked, but it only worked because we did a lot of work to make it happen. The Firebase real-time database took a new approach. Rather than having a client talk to the server talk to the database, the client talks directly to the database, writing data and listening to changes. The database then updates every connected client when that change happens instantly. Instead of making a request and getting a response, now developers could set up handlers and just listen for the events they're interested in. Events provide built-in meaning. Rather than having to create my own representation of, well, okay, a new record was added to this list, so you probably want to update it somewhere. Instead, I can just listen to the real-time database for a child added event. So this let me do more with less code, and I don't have to run my own servers. So that's why the Firebase real-time database is so great. And at this point, you may be wondering, wait, isn't this supposed to be a Cloud Functions talk? So the real-time database is great at synchronizing data between clients that connect to it. But what happens if I want to synchronize data from another source that's outside the database? What happens if I want events in the database to trigger side effects like sending an email or a push notification, something that happens outside of the database world? Well, to make this work, I'm right back to running servers. So I run a server that listens to the real-time database and communicates with external APIs. then writes back to the real-time database, which then syncs with all of the connected clients. This is still easier to manage than the old model because you kind of have the real-time database in the center. But I have to do all the work of setting up the infrastructure to bridge the gap between my server, the third-party API, Firebase, and the client application. And this is where we get to Cloud Functions. Cloud Functions for Firebase bring the event model that worked so well for the real-time database to your entire application. Cloud Functions are the computational glue that bind your app, Firebase, and the rest of the development world together.
Thanks, Michael. So, what are Cloud Functions, and how do they work with Firebase? So no conference is complete without a few buzzwords, so let's get them out of the way. Cloud Functions is Google's new serverless environment. See? There's no servers. OK, so obviously, there's actually servers somewhere. So what do we mean when we talk about serverless? Well, Cloud Functions are backend code. But they typically take the form of lots of backend pieces. You'll sometimes hear the term microservices, because the programming model breaks your backend into individually managed components. But in the old world, you had to set up a set of machines to run a backend. So this idea of microservices, many backends, sounds really intimidating. But it's not with Cloud Functions, because your code is your infrastructure. As we'll see later, the Firebase command line tool can look at your code and create all of these microservices and manage them for you. Now, because you've broken up your backend into these small pieces, Google can do some great heavy lifting for you automatically. A Cloud Function will be able to scale up automatically under increased load. When that load dies down, Cloud Functions will scale down those instances all the way to 0, which means you pay no bill just for being available. With Cloud Functions, you only pay for the time that your Cloud Function is actually handling a request, not just for the time you want to be available to handle a request. Now, because the internet speaks HTTP, HTTPS, we've designed Cloud Functions to let you build very powerful HTTPS endpoints. Or, if you like the event model that Michael talked about, you can directly handle events in Firebase and Google Cloud Platform with your Cloud Functions. So this is the simplest Cloud Function that we have. With just a few lines of code, we've written a fully functional, auto-scaling web backend. Let's break it down. And first, we'll check out this exports.hello world. Cloud Functions are written in JavaScript for the Node.js environment. In Node.js, every file is called a module. And everything inside a module is private unless it's publicly exported by attaching it to the global exports object. We'll export our Cloud Functions so that Google can find and run it. And the Firebase command line tool will name our Cloud Function Hello World, just like it is in the code. To define our Cloud Functions, we'll use the Firebase Functions SDK. This is an open source SDK we've written to help make it easier to build a Cloud Function. Here we say that we're creating a Cloud Function that should be accessible over HTTPS. Cloud Functions are built on Express.js, a very popular Node web serving framework. And in our product, we let you have access to the raw request and response objects. This will let you build very powerful and free-form backends very easily. Since our demo is trivial, we'll just send a static response back every time. Now, back to that code as infrastructure idea. To deploy our Cloud Functions, all we need to do is run the command Firebase deploy with the Firebase command line tools. The command line tool will notice that we have functions in our project. We'll load our code, analyze what's been exported, notice this hello world function, compare it to production, and create, update, or delete functions to match production with your code. Now, here's a more complicated example. Let's say we have a message board. We're going to add a feature to our message board so that whenever a user creates or modifies a message, we update the message's timestamp on the server. So the Functions SDK has a common pattern. First, we pick the service that we want to integrate with. Here's the Firebase real-time database. Next, we pick which objects we want to observe. Now we've given a pattern for the references inside the database that we want to observe. And finally, we pick the events we want to observe. Here we've said we want to observe all write events to any reference that matches this pattern in the Firebase real-time database. Our function will be called with an event object, which is very powerful. Event.data is just like a data snapshot in the Firebase SDK, but with some features that are exclusive to Cloud Functions. For example, event.data.ref would have given you a reference to the database that acts as the original user. But here, we've locked down that timestamp field. So we use admin.ref to make writes to the database that are normally prohibited by end users. So we'll update the database and return that operation back to Cloud Functions so it knows to stay alive while there's work happening in the background. So we've shown you two quick demos that integrate with HTTPS endpoints or the Firebase real-time database. But we support so much more. You can have a Cloud Function run to handle every message in a topic for Google Cloud PubSub. Or you can have a function run on every creation or deletion of a user in Firebase Auth. You can integrate with cloud storage for Firebase, or even have custom code run in response to a conversion event in Google Analytics for Firebase. In case you haven't caught the news yesterday, Cloud Functions now integrates directly with Firebase hosting, and we're always at work to bring you more providers of events. So you can use Cloud Functions to connect two Firebase features. For example, you can send a push notification in response to any change in the Firebase real-time database. Or you can integrate Firebase with third-party APIs. What if instead you wanted to send an email? You can just sign up for an email provider and call their API inside your Cloud Function. And you can do some really cool stuff when you flip this around. If you connect an API to Firebase, imagine if you're building a product and you maintain your documentation as Markdown in GitHub. You can have a Cloud Function that listens to a GitHub push, and then use that Cloud Function to compile the Markdown and then deploy it to your product page with Firebase hosting. So today, we're going to show off some Cloud Function demos. I want you to think about how you can use Cloud Functions to build your product, to automate your workflow, and to grow your business.
So we wanted to think about Cloud Functions as if we were developers, building a startup from scratch. So Thomas and I decided that we're going to have a Firesale app. Firesale is a simple concept. It's an online store that sells one thing per day. Who needs shopping carts or category pages? We're just going to sell one thing, and you either buy it or you don't. So rather than explain more, I'm just going to jump right in. Can we switch over to the laptop? So this is Firesale. And as you can see, today's deal is the Google Gnome. Now, the Google Gnome is pretty cool. It sits outside. You might have heard this announced in early April of this year. It sits outside. It can tell you the weather. It has this cool red hat. So I come to the page, and I'm immediately interested. I got to have this thing. So I'm actually on Thomas's computer here, so I'm going to sign in. And that's using Firebase Auth to sign in using Google authentication. And I scroll down to the bottom here, and oh no, there's only 40 of these left. I need to act now. So let's see, I'll just click the cart button, and it pulls up a form. Since I'm already a user, I've got the address filled in, but I need to fill in my credit card. So I will enter a totally real and legitimate credit card number. And let's buy it. So it took a couple seconds, and now I've placed my order. And you can see it says that we're processing your payment. And in the background, what we're doing is we have sent this to the payment processor, who is now processing it out. And you can see it's updated, and the payment has been received. So in just a couple seconds, I bought a product on Firesale. But of course, I haven't told you anything about how I built it. Can we switch back to the slides? So what went into making Firesale? First, as with everything, we tried to focus on the user. We thought about the ideal experience that we wanted Firesale to have, and then worked backwards to figure out how we needed to build the app. For this app, the most important thing was to remove friction everywhere we could. If I come to Firesale, there should be as little time as possible between seeing the deal for today, deciding I absolutely have to have it, and making that purchase. Every moment of friction, every roadblock between me and that purchase is a chance that I might decide, hey, maybe I don't actually need a smart gnome to sit outside my house. So we don't want that. So we designed our app experience around being fast, focused, and free of distractions. That led us to a few decisions right away. First, we built Firesale as a progressive web app. Web apps are the fastest way to get someone's eyeballs on the content you want them to see. There's no install, no booting up, and no friction. Plus, your app is instantly shareable via a link. For e-commerce sites like Firesale, in particular, web apps are a great choice and a natural one. Second, we realized that with the simplicity of our store, this is actually a great fit for the Google Assistant. What if someone could shop Firesale just by speaking to the Google Assistant? Thomas will tell you more about that in just a little bit. Most importantly, because we're a startup, or more accurately, because we're two Google engineers who have deadlines on a talk and we're pretending to be a startup, we wanted to offload as much work as possible. So we wanted to use Firebase and third-party APIs everywhere we could so that we are doing as little work as possible. So let's talk a little bit about building your app with Firebase and Cloud Functions. When building an app with Cloud Functions, one thing I would encourage you to do is think small. Don't worry about the 1,000-foot view and how every piece fits with every other piece all the time. Firebase gives you a hub for your application with products like the real-time database. At any given time, you should just be figuring out how to connect a single new thing, whether that's a new type of user interface, a third-party integration, or whatever else, to that hub. You don't need to be thinking about, oh, I have this massive application and it does all of these things. Cloud Functions lets you break those apart into smaller problems that you can solve one at a time. So the first thing that we needed when we were building this app is the deal page that you see when you first come to Firesale. So we needed that first load experience to be as fast as possible. So I built a Cloud Function to render the page's HTML and connected it to Firebase hosting using the brand new integration that we launched yesterday. Now, I'm not going to get into all the details of how I built that here, but David East will be doing a deep dive into performant web apps on Firebase hosting on this stage at 5:30, and if you're interested, I'd really encourage you to check that out. So now I've painted my deal page. Everyone can see the deal, read about it, find out what it is, but of course, they also need to be able to buy it. So now we needed interactivity. But here, I had a little bit more breathing room. No one is going to come to the page and within half a second decide that they need to click to buy. They're going to read things for a few seconds and decide, hey, do I want this or not? So for the interactive parts of the app, I used the Firebase web SDKs. I used Firebase Auth, as you saw, to sign the user in using Google credentials so that I can remember who they are. And I used the real-time database to synchronize the order status so that as it updated, it would instantly come to the web app. Now, one of the most important pieces of this flow was placing the order itself. Now, Thomas and I tend to agree on most things, so it was a little bit surprising when we started arguing a bit about how this should be implemented. I wanted to write new orders directly into the real-time database, but Thomas thought it might be a better idea to use the HTTP API with Cloud Functions to build it as a JSON REST API. After we discussed it for a little while, we realized that there are good situations for each, and we thought that it was worth sharing. With the real-time database, you're writing directly to your permanent data store. You don't have to worry about translating requests or responses from a certain format. You are just deciding what your data model is, and then you're writing that into the database. Additionally, Firebase's security rules can be used to manage authorization and access control at the data level. So you don't need complex authorization systems that you build yourself. Instead, you can just rely on Firebase rules to take care of that for you, And all of this is accessible directly from the client. Finally, the real-time database SDK has some great features for reliability, so your data will be synced even if you have a spotty network connection while you're using it. Now, HTTP functions have their own advantages as well. For one, there is no data buildup. There's no stored request when you make a request to an HTTP function. So for ephemeral requests or things that aren't going to permanently alter your data model, you might prefer an HTTP function because then you don't have to first write to the database and then later clean that up once you've finished the task. In addition, with HTTP functions, you have full control over the API. The Firebase real-time database speaks in JSON objects. But with an HTTP function, you can speak in whatever language you want, whether that's JSON or XML or HTML, or even if you just want to actually generate an image on the fly and send that back as the response. Any of that is possible with an HTTP function. Finally, HTTP functions can be connected to Firebase hosting, and expensive or high traffic operations can be cached in Firebase hosting's global CDN to reduce load, executions, and burdens on your cloud functions. So after we talked through all that, we decided that since we are creating a new order in our system, and that's permanently affecting the data model, that we were going to go with a database trigger for this. So I built a cloud function that listened for new orders that were created in the real-time database, and as soon as that happened, it would instantly send out to the payment processor and say, hey, we have a new order, the user needs to pay for it, here's all the details that you need. Then the payment processor would process that and send the data back to us that says, OK, the order's paid. And that's what you saw in the demonstration right there. So that's the web app interface for Firesale. But while I was busy building that, Thomas was doing some really interesting work of his own. Thomas?
Thanks, Michael. So Google Assistant is a great way to build an immersive experience that follows your users around. And it's a great match for Firesale, because we targeted users who like cool gadgets. Now, if you've never programmed for the Google Assistant before, it has a unique feel, because your code doesn't actually run on the customer's device. First, you register a series of actions that your agent supports with the Google Assistant. The Google Assistant will invoke these actions on behalf of the user, either if the user directly asks to speak to your agent, or if the Google Assistant thinks that your action can fulfill the user's more generic request. Now, this means that every agent needs a backend that the Google Assistant can call. And of course, we're talking about it today because that backend can be a cloud function. So the Google Assistant is a very rich topic, and we're not going to go into the SDK in a lot of detail. If you want to get started building assistant apps in Node.js, check out the Actions on Google SDK. This SDK lets you program in an intent-based model that might feel familiar to Android developers. And it will expose an HTTP endpoint that you can then use, or that you can then host with a cloud function. If you're building an assistant app from scratch, you might make one monolithic cloud function that serves your whole app. But this could lead to a more rigid system than you actually want. So here's what happened when I first started hacking on the project. I like to create a class so I can test each method separately. And then I decided to create the handler for the main intent. Well, OK, I want to get today's daily deal, so first I'm going to get the string ID for today's deal, some time zone fiddling and things like that. Then I'm going to fetch it from the database, and my actual model has some normalization. And this is all some really awkward boilerplate before I get to the fun stuff. So I started writing this, and I thought, haven't I seen this whole boilerplate before? Didn't Michael just give a demo about how he wrote this for the web app? It felt like I was reinventing the wheel. So I decided to look at the whole app together with an eye for how I could refactor and reuse some of this code. So this is my second pass. Oops. Oh, sorry. The web app has two functions we should look at. The first is exports.web. This is an HTTP function that integrates with Firebase hosting. This is a full website. It's HTML. So I can't use that to serve my assistant API. but I could probably reuse some of the code inside of it. So after refactoring, here's my second attempt. I refactored that deals code into its own interface for handling the deal model. Then I construct my bot class with an instance of that model. Now it's only one line to get this, and that line is shared in both my code and Michael's code. In my index.js, I'll create a concrete instance of this model accessor. I'll pass it to my nice testable controllers, and then I'll bind them to different cloud functions. If you want to see why I write my cloud code this way, you can check out Cloud Functions, Testability, and Open Source tomorrow at 2 p.m. on this stage. So we can think of Cloud Functions as either exposing a front end or enforcing consistency in the back end. With our new design, both our assistant and web interface are a cloud function that supports or builds a front end. We keep these small and use code reuse wherever it's possible. Now, because we know we're using the same model, exports.onOrder can be shared with zero side effects, because this function is in the second category. It will automatically respond to the event that we created in order, and then make sure a side effect happens. So let's see it in action and switch to the demo screen. So I am going to ask Firesale for today's deal.
Sure, here is the test version of Firesale.
Today we have a sale on Google Gnome.
That's cool. I want to know more about this. Tell me more.
Google Gnome is like having a tiny, little meteorologist at your beck and call.
Oh. How much does it cost?
The Google Gnome costs $130.
Oh man, how many are left?
There are 37 Google Gnomes left.
Okay, well, it's a good thing Michael was using my account and I already have one on order. So now all we need to do is switch back to Michael so he can build an admin panel and actually fulfill that order. Can we switch back to slides?
OK, so now we have built up the interfaces that our users are going to be using when they interact with Firesale. But we also need to handle the back office of our store. So we needed to build an admin panel. Wait, I'm sorry, this looks like it's the wrong slide. We needed to build an admin panel. Don't get me wrong, building tools for your team to use is very important. But if I'm spending all of my time fiddling with an admin panel that only myself and Thomas are going to use, I'm not really focusing on the user. So I got to thinking, what if I just didn't build an admin panel? As it turned out, our payment processor had already built a pretty sophisticated product and order management interface of its own. So instead of building an admin interface, I built 3 webhook functions using Cloud Functions that synced data from the payment processor back to the real-time database. I built one that would sync anytime a product in our payment processor changed, another that would sync every time an order changed, and a third that would sync every time the daily deals and which days had which deals changed in the payment processor. And so I got to have my admin interface without having to build it, which I was really happy about because I just saved a lot of work. So let's take a look at how that works. Can we switch over to the demo? So here you can see I still have the web app up on this side with the order I just placed. And on this side, I have my Stripe interface for my payment processor, which has the products that I'm offering. So today's deal was the Google Gnome. I'm going to click through to that. So you can see that all of the data that was populating the initial page when I loaded it, all of that stuff is right here. And if I made changes here, that would automatically make changes that updated the page when it was rendered. But what I'm talking about today is order fulfillment. So since Thomas and I are just pretending to have a startup, we have a bunch of pretend Google Gnomes just laying around the office, and we're going to manually manage fulfillment because we haven't figured out a process to have a third party do that or anything yet. So you can see that I have a new order here that is paid, and I'm going to click through to that. So this is the order that I just placed a little bit earlier. And so now from Stripe, I'm going to say, well, you know what? I've actually shipped this out. So I've used the postal service, enter a fake tracking number here. That looks pretty good. So I'm going to click update here.
That
Throw
works.
in the password. Oop. Hang on. There we go. So I fulfilled the order, but what happens now? Well, Stripe, luckily, integrates really well with webhooks. And so any second now, all right, the demo gods are not necessarily on my side right now. Let me take a look at this. Maybe I fulfilled the wrong order. I'm not sure. Let's try this one as well, just to be sure. Tell you what, sometimes the demo gods are just not on your side. So anyway, what happened every other time I ever tried this is that the web app on the left immediately updated with the order tracking information for my order, and everything happened without me having to make any changes in the application side or with my application code. All right, I'll try the third one. Maybe.
I think when we were prepping our demo, we forgot to clean out the data from our last version. So.
Oh, okay, that might be the fact. Let's try the third one. Here we go. Oh! Hey, there it goes.
Never mind.
All right. I gave up too early. Thank you, whoever shouted out, to keep me going. All right, so that's Firesale. Back to you, Thomas.
Wow. It's a good thing it worked because I gave him cool guy shades in the next slide. Can we switch the slides? Okay. So Michael found some great shortcuts that do actually work when building the admin panel. So this leaves me with the ops work. So people know that ops personnel tend to handle emergencies at night. They're less often known for handling all the chores during the day. The talk I mentioned earlier will cover some of the monitoring and alerting tools you can use with Cloud Functions. But like Michael, I'm going to use Cloud Functions to handle some automation so I can get out of my chores too. Michael decided that we should make sure that production reflected master as soon as possible. And I said, okay, I can take care of that with a Cloud Function. But after I made that assertion, I started to worry because, yes, GitHub has webhooks, but a webhook should be responsive. And this might not be a good fit because a GitHub webhook will have metadata about the commit. I'm going to need to actually download that tarball. I'm going to need to untar it. I'm going to need to download all my dependencies if we don't check those in. We write our functions in TypeScript, so I'm going to need to compile that code and then do a final deploy. It probably wouldn't be a good idea to do that in just a standard HTTP request. But then I had an idea. I don't actually have to do that. Instead, I wanted to have a way where I can have a quick endpoint that would respond to GitHub before any timeouts, which would then kick off an asynchronous process that could do all that heavy lifting in the background. So to do this, I split my Cloud Function into two pieces and connected them with Google Cloud PubSub. My first Cloud Function would receive push notifications from GitHub. It would then compare the information about that Git push to decide whether or not the commit matched the filters for which branches should be deployed to which projects. If it matched a filter, it would then enqueue a deploy job over PubSub. The next function could then wake up in the background and run with a much larger timeout or much larger memory requirements. In fact, I now had so much extra time that for some extra pizzazz, I added a new API call to announce the start and stop of every deploy inside of our chat room. So And that's not all. I can automate more of my workflow. I can create webhooks that will check whether I've remembered to do my chores, and then hook them up to a cron-type service so that I will have a safety net that periodically checks. It might, for example, remind me that it's 8 p.m. and I haven't queued up tomorrow's daily deal. So now with this, my op duties are automated, and I can pretend to be a cool guy too.
So at this point, our app is in pretty good shape. We have a working app on 2 platforms. We can manage inventory and fulfillment, and our development process is stable and automated. What's left to do? Well, we could connect user signups to a business intelligence API like Clearbit. This would let us turn our users' email addresses into rich data about the user, the company they work for, their social media accounts. So once we do that, what happens if the customer reaches out to customer support? Now we have all kinds of data about the user that we can use to help them out faster. Or maybe I want to take all of the orders that are created within Firesale and put those into BigQuery, Google Cloud Platform's big data analysis tools. This would let us do rich querying over our order history to find purchase patterns or other things, or we could build great sales dashboards with Data Studio. Or maybe instead we'd rather focus on re-engaging users when new deals come out. So we could build a scheduler that will call a webhook every time a new deal comes out, and when that happens, trigger push notifications or emails every time a new deal goes live. Of course, these are all just examples that I came up with off the top of my head. But the really powerful thing about Cloud Functions is that you can hook just about anything up to just about anything else. And of course, this doesn't just work for Firesale, but for any app you're building, or even apps that you've already built. So I would really encourage you to dive into Cloud Functions. Think small. Think about the little pieces that you could fit together with Cloud Functions to accomplish something big. We're really excited to see what you build. That's all we've got for you today. If you want to learn more about Cloud Functions, there are some awesome sessions coming up. I've listed a few of them on the screen here. Also, if you want to talk to either of us, we're both going to be heading over to the Firebase sandbox area right now. Feel free to hit us up with all of your questions about Cloud Functions, Firebase, life in general, I don't know. Anyway, thank you very much. That's it.